Hello everyone, I am Dipanita and I wish everyone a happy Holi. Welcome to the fifth interaction session of network analysis. This week, Sir had shown how to use Laplace transform for solving different circuit problems. So, okay, okay. So today for the tutorial, we'll be doing a few of the problems, like we'll solving a few of the circuits by using Laplace transform. So before we go into the solving of circuits, like first, I hope everyone has gone through the videos where Sir had showed like any signal which is in the form of x of t can be converted to the frequency domain using a Laplace transform, which is actually equal to minus infinity to infinity e to the power minus st, the signal whichever it is into dt. This is the basic way in which it is converted to the frequency domain. And a few of the things we should remember for using it in our circuits are certain signals, Laplace transform of certain signals. For example, let's say Laplace transform of u of t. Now, u of t is a kind of signal that actually starts from 0, like since 0 it has a constant magnitude of 1, right? So these kind of signal, if we convert it using Laplace transform, we will end up with the like in the frequency domain it will be equal to 1 by s. Then any signal when e to the power at is actually multiplied with the signal u of t, it turns out to be whatever the signal is minus whatever the value that is at the exponent of e to the power something. That is, in general, if we are to write, it is e to the power at if it is x of t. So in whenever when we perform Laplace transform of x of t, if it is x of s, we can write this in the form of x of s minus a. This will come in very handy. Sir has shown how to derive it using partial fractions by integrating the integral. And a few other ones are like Laplace transform of I think ddx. Yeah. So differential of a particular function, it can be written in terms of s into x of s minus a initial condition x of 0. Now if the initial conditions are not given, uh, then we can directly write like Laplace transform of ddx of dt of x as s of x of s. So if initial condition is equal to 0, then there is Laplace transform of integration of x of tau d tau. So this can be written as x of s by s. These two things will come in handy in case of inductor and capacitor whenever we come across these elements in our circuits. So then we will come across terms where we have to convert it, like since this x of t can be in the form of a constant voltage, or it can be in the form of sinusoidal or sinusoidal voltages, or something with exponentially decaying or increasing. X of t can be various of this. And so another two thing that will come in handy is Laplace transformation of sine of omega t, where omega is the frequency. It is of the form omega by s square So if I transform it, omega of s square plus omega square, and Laplace transform of cos of omega t is s by s square plus omega square. Note, for like all of this function, if e to the power at is present, for example, in case of suppose cos of omega t, suppose Laplace transform of e to the power at is present, cos of omega t, then what will happen is, in place of s, it will be shifted, s of s minus a. It will be like this, s minus a whole square of and omega square. So in any function, if e to the power at is present, we will replace s by s of a, s minus a. These are the basically pretty much all the formulas that we'll be using in our circuit today. So let us solve one basic circuit first, then we'll move to the previously ruled assignments. Everyone has gone through the video and seen these formulas, right? How it is derived, and you don't have any question, I hope.
Yes, ma'am.
No,
Yes, ma'am.
ma'am.
Okay. So for the first practice problem, we have a simple circuit. Uh, it has a it is connected to a voltage source VA U of t, and let us say there is an initial current of I0 in the circuit. Here, like nothing specific, I'm not giving any values, this is just for practice. So yeah. So let us assume that through the inductor initially some current I naught 0 minus was flowing through it. So now you have to finally calculate what is this I of t. So the first step in case of solving circuit using a Laplace transform is, so first step is to write the to redraw the circuit in terms of like the frequency, right? In terms of S. So when it is mentioned that there is some current that is flowing through the inductor L naught, so the inductor can be drawn something like this. So this also sir had shown in the circuit, instead of like writing the equation with an initial condition, that is x x of s minus x of 0. Instead of that, we can also write it as a inductor with a current that is flowing parallel to it. So this is the initial current I of 0 minus. Just the instant before this circuit was this voltage source was connected to this circuit, this particular current was flowing through it. So let us say this is R and this is the voltage VA U of t, right? Now when we write it in terms of the Laplace transformed circuit, so the voltage source is given as VA into U of t. So what will be the Laplace transform of that?
V by
Can
S.
Yes. So it will be VA by S. In case of R, it will remain as R. The current IS will be flowing through it. So instead of writing this as a like a parallel to the L, we can also write it in terms of series circuit to make the circuit simplified. We can write it in terms of a voltage source, right? So you all know about like how to convert a suppose there is a impedance like this, across which there is a current flowing through it, like current flowing through the parallel branch. Suppose this is resistance, this is one resistance R. Its equivalent circuit can be written like this, right? With a resistance, right? Everyone is aware of this?
Yes, ma'am. Yes, ma'am.
Okay. So R, and this is suppose I, it will be Ri. This will be the voltage. So similarly here too we are writing kind of this. So Laplace transform of I of 0 will be, since this is a constant, so it will be I of 0 by S, right?
Yes, ma'am.
Yeah. So here we are directly writing the voltage, so minus plus. So it is I of 0 by S multiplied by, for an inductor, in since the voltage drop, we are writing all the voltage drop across the different uh, circuit elements so that we can apply KVL. So the voltage drop across L will be L di by dt. So if we convert it into the frequency domain, it will be equal to L into S di by dt. Initial condition we are writing it separately, right? Or you can just write minus of I of 0. It is up to you. So this into L of S. So the voltage drop here will be I of 0 into L. Is this okay?
Yes, ma'am.
Now we can apply KVL. Once we apply KVL in this loop, we'll be able to solve for I of S, right? So it will be VA by S minus of R into I of S minus LS into I of S, right? And plus, since we have a negative sign here, so plus L into I of 0 equal to 0, right? So let us separate out the I of S term. So it will be R plus LS into I of S, which is equal to V of A by S plus Li of 0, right? So I of S is equal to, so if we take this to the denominator, it is V of A by S into R plus LS plus L I
Yeah.
of R plus LS. So yeah, so we'll write it here now. Uh, so now the next step, which would be, so this is the second step where you form the equation. The third step is to write it in the form so that it can be converted back to the time domain. So I of S, so here it is written in terms of S plus something plus LS. So how can we convert it back? So let us say it is, we are uh, we are writing in terms of some partial functions so that the S and the R plus LS term gets separated out. So VA is outside, so maybe I'll take it to the next page. So I of S, it is VA by S into, so let us make the S term free, because all the Laplace transform we have seen had S plus something, right? So we will divide the numerator and denominator by L. So it is VA by L, S into R by L plus S. This is one term. The other term is, So if we divide the numerator and denominator by L, it is R by L plus S, right? So this part is constant and independent of S. We will take it out, VA by L. Now suppose we are to write in terms of 1 by S and something into S plus R by L. Suppose we had written this part. What will this part be equal to? If we had simplified, it will be S plus R by L minus S by S into S plus R by L. So basically there is an R by L factor that would come up if we write it in this form. So we have to multiply an inverse of it, L by R, so that it balances out what we have written here, right? Now this part is fine. It is I of 0 times 1 by S plus R by L. So this is of the form of 1 by S plus A. This is of that form, right? And now what we have to do is, this is in terms of S. Now we have to convert it back to the time domain, that is I of t. So here LL cancelled, it will be V by R, and we perform inverse Laplace transform to the equation that we have, plus I of 0. So inverse Laplace of 1 by S plus R by L. So what is inverse Laplace of 1 by S? It is U of t, right? We have seen in the first here, right? 1 by S is equal, inverse Laplace is U of t. Mind that all these are multiplied by U of t. All the equations that I have shown are actually sin omega t into U of t. Then only the integral will be from 0 to infinity, because U of t exists only above 0. So in this case it is U of t minus, now this is of the form S plus some constant A. So it will be U of t multiplied by e to the power minus R by L of t. You see, in the first we had written it like this. So e to the power at U of t is equal to S minus A, 1 by S minus A, right? Now I of 0 minus, similarly Laplace transform of this is minus R by L into t U of t. So finally the current expression would be V by R minus e to the power minus R by L of t plus I of 0 minus e to the power minus R by L of t whole to the whole multiplied by U of t. This will be the response, the current response of the circuit. So this part is the forced response, and this is the natural response of the circuit that we earlier had solved using differential equation in the previous classes.
V by R into 1 minus e power minus R.
Sorry?
V by R into 1 minus e to the power minus RT by L.
So I have only taken out the U of t as common, right? Is there anything you want to say on this?
Ma'am, can you explain once again from the
So
second step about taking VA by L common?
okay, I see. So uh, see, so whenever you have a circuit, you have an equation something like 1 by S into S of S plus A, something like this, okay? Now taking the, you do not know how to take the inverse Laplace transform of this particular equation. You know how to take the Laplace inverse of 1 by S or 1 by S plus A. So the best option would be separate out this fraction. So in the numerator, if you write s minus s, suppose if you write numerator as a and you multiply it by 1 by a, right? S into s plus a. This is the same thing as what I have written here, right? A will get cancelled and it will become 1 by s of s minus a. So
Yes.
now you just write s minus s to it. Again, it is the same thing, s of s plus a, because s will get cancelled, a will get cancelled, and it will end up to the same expression. Now you separate out the terms. So s plus a you take so s plus a you separate out and minus s you separate out. So s plus a, it will be s into s plus a. I'm just separating out this part from the other part. So it will be s into s plus a. So the s plus a will get cancelled. Here s will get cancelled. So it will be 1 by a into 1 by s minus 1 by s plus a. This is what we are trying to find out. So in this case, what I did, so v by where did my pen go? Yeah. So v by va by l, this part is constant, so I have taken it out. Now in this case, it is s r by l plus s, right? So in this case, the steps are like I had taken l by r outside and multiplied by r by l. So it will get cancelled and it will be 1. So it will be s into s plus r by l. Now on top of it is the same thing, right? Now on top of that, I'm adding s and subtracting s and then separating out the term. If this is difficult to follow through, one more thing what you can do is, so so you have this kind of thing. The second approach would be like writing a and b. Suppose you write it as a by s plus b by s plus a. Okay, and then you calculate it. So 1 by s into s plus a can be written in terms of a by s plus b by s plus a. You want to figure out how to write this in the form of this expression so that you can take inverse Laplace transform and convert it to time domain. So this equation you will solve for a and b. So let's say you take the denominator on the right hand side. So it will be 1 equal to a into s plus a. By s is already there and b denominator is s plus a, so it will be b into s plus a, right? So this will get cancelled, this will get cancelled. The equation that is forming is a into s plus a plus b into s. Now put one value of s in the equation so that one of the term goes to 0 so that we can figure out the other term. For example, in this case, let's take s equal to minus a first. Okay. Guys, do try to join in time. So, yeah. Now putting s equal to minus a into this equation 1, what will happen is 1 a of minus a plus b of minus a. So this will be cancelled, so it will be 0 minus ab. So b is equal to minus 1 by a. This is 1. Then again in equation 1, suppose you put s equal to 0. Okay. So what you do? The equation 1 will become 1 equal to a into s is 0 plus a plus b into 0. So it will become a into a equal to 1. So a is equal to 1 by a, right? So now you know the value of A and B. You can write it as 1 by A of S plus minus 1 by A of S plus A. So if you take 1 by A outside, it is 1 by S minus 1 by S plus A. So if the equation is too complicated, you can solve using this also. So you see the expression that we obtained here and the expression that we obtained here are the same thing, right? With
Yes, ma'am.
practice, actually you will be able to easily figure out what will be the coefficient. You practice 2-3 times, simplistic expression you will be able to figure out easily. But if this expression is too complex, then you can go through this method, like write A and B and figure out the coefficients of A and B. Is it fine?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay, so any other doubt with the first problem, I mean the practice problem that we have shown? Then we can move to the next question. Shall we move ahead?
Yes, ma'am. Yes.
Okay. So this is from the previously rolled out assignment that we have. So a circuit in which a inductor and a resistor are connected in parallel, and it is connected to parallelly to a voltage source. It is connected to a capacitor which has an initial voltage of 15 volt. So in case of inductor, we have seen while we were drawing the circuit, when they had initial some current flowing through it, we would write a current in parallel to the inductor. In case of voltage, in case of capacitor, what it acts as when it has some sort of initial voltage and there is no other voltage source connected here, so we can easily draw that it is kind of a voltage source connected in parallel in series with the capacitor. This voltage is equal to the initial voltage 15, which is for the capacitor. So we can replace the capacitor with a capacitor and a voltage source, right? Because this is the natural response that we will be calculating at when the switch is closed. Until the switch is not when the switch is not closed, the capacitor has an initial voltage of 15 volt, right? Because initially the circuit had an initial voltage. So we have solved this kind of problem using a differential equation earlier, right? So now we will just convert, the first step is to convert it to the S domain. So we do the first step and convert the circuit to S domain. So we redraw the circuit. Now the switch has been closed, so I'll draw it as a straight line, but it had an initial voltage, so there will be a kind of a voltage source which will now work as a source. So now it is given as 42 Henry, right? 42 Henry can be written as 42S. Is it fine?
Yes, ma'am.
There is a current I1S. I am converting all of it to the frequency domain, so it will be I2S. So the resistance is 222, it remains as it is. The voltage is given as 15, so it will be 15 by S. And for capacitor, it is 1 by CES, right? When we convert it to the frequency domain. So C is given as 1 by 3108. So 1 by C will be reverse of this. So it will be 3108 by S. This is 1 by CS, right? Now we have the circuit. Let us assume that a current I of S is flowing. So we have I of S is equal to I1 of S plus I2 of S, right? This is the condition right now. Now we are asked to find I1, I2 and VC. So in order to find I1 and I2, we first need to find what is IS, right? Then we can figure out what are the like different currents that are flowing in this branch. So we can either apply loop analysis here, or the best option would be like to simplify the circuit. Since we are using the frequency domain, why not simplify the circuit, figure out IS, and then figure out the contribution of I1 and I2. So let's start let's simplify the circuit further. So these two branches are connected in parallel. So the net Z that we have, so if we simplify these two branches, it will be the inductor is in parallel with the resistor, right? So the net Z will be, inductor is 42S into the resistor 222 by 42S plus 222. Let me write the S in this way. Um, then there is a voltage source and a capacitor. So this is 15 by S and this is 3108 by S. Now this is the current IS that was flowing. Now we have one single circuit, one single loop to solve. So now whatever the value of IS will be, it is the available voltage V of S by whatever the Z is in frequency domain, right? So the available voltage that we have is 15 by S, and the net Z will be, now the capacitor is in series with the parallel combination of the inductor and resistor, right? So it will be the capacitor value 3108 by S plus this parallel combination 42S plus 222 by 42S, sorry, it will be multiplied here, 42S plus 222. This much is clear to everyone?
Yes, ma'am.
Okay. So now we simplify this expression. So, sorry. So we have I of S is equal to, so it will be 15 by S. So 15 by S, let's simplify the denominator first. So it's 3108 into 42S plus 222 plus 42S plus 42S into 222, and it will be multiplied by S. So in the numerator, denominator we have S into 42S plus 222, right? So this is now just a bunch of multiplication that you have to simplify in order to get I of S, right? So let's use the calculator. Where did I keep the calculator? Yeah. So we take this denominator to the numerator. So it will be 15 by S into 42S plus 222. Hopefully this much big value won't be given to you. So anyway, this is just a straightforward multiplication. So 3108 into 42, it is. So 130,536S plus 222 into 3108. So 689976 plus 42 into 222, 9324 s square, 9324 s square. Now this really looks kind of a ugly expression. So so the denominator, since we come across this s square term, we kind of get a hint that this will be either in the, since we also find that s is also in the numerator, s plus something, so this entire expression has to be converted somewhat into, you know, such expression that is s square plus omega square, or s plus a whole square plus omega square, right? Then we can like use Laplace transform to convert it to either cos or sine of omega t, because you see uh, here you see the denominator is kind of in terms of s square. So we have to simplify our expression further. So the coefficient of s square needs to be getting rid of, right? So you divide the numerator and denominator by 9324. So it will be 15 by 9324 into 42s plus 222. Let's now keep the numerator as it is. So if we divide the entire denominator, since we had also divided the numerator here, so when we divide it, it is s square divided by 9324 is 1. Now the s term 130, so it will be, I'll maybe write one more step. So 9324 by 9324. So it is 130536 by 9324 s plus 689976 by 9324. So this comes out to be 15 by 9324 into 42s plus 222 by s square plus, so let's do this, 130536 divided by 9324. This comes out to be 14s plus 689976 divided by 9324, 74. So see, the denominator now kind of looks reasonable, like to be factorized into two components, or like, you know, write it in terms of 1 by s plus a whole square plus omega square, right? So this is the expression of I of s, but we do not need I of s. What we need is I1 of s and I2 of s. So now let us come back to this original circuit. So this is the total I of s, and there is this inductor branch and the resistor branch, and this is the I of s current flowing through it, and this is so I2 of s, and this is I1 of s. So if we are to find I1 and I2 of s, this is 42. So I'm just writing only this part of the circuit where I1 and I2 are there. So this is 222. So now in order to calculate I1 of s, what will be I1? I1 of s will be the current that, whatever the current that is flowing through into this node will get divided into the branch in the reverse ratio of their impedance. So for I1s it will be, what will be the value of I1s?
Is multiplied by
Hmm.
222
Yes,
divided by 42s plus 222.
exactly. So this is the total impedance. This is the for the reverse current ratio 2 to 2 of the resistive branch. This will be I1 of s. So if we simplify I1 of s, I1 of s will be 222 into 42s plus 222. And what is I of s? 15 by 9324 into 42s plus 222 by s square plus 14s plus 74. So now we can cancel this term. So we end up with 15 into 222 by 9324 into 1 by s square plus 14s plus 74. Now the first so let us look whether this can be either factorized or written in terms of s plus a whole square plus omega square. So 14 can be written in terms of 2 into 7, right? So if we write s square plus 7 whole square, this comes out to be s square plus 14s plus 49. Now 74 minus 49 is 25. So it can be written in terms of 5 square. So this entire denominator, instead of factorizing, what we can write it in is as s plus 7 whole square, sorry, this won't be square, s plus 7 whole square plus 5 square. Everyone okay with this?
Yes.
Ma'am, is there any method to know this?
Sorry?
How did you found that it will be f plus 7 square plus 5 square? In sense, is there is, do you have any shortcut method to find these kind of equations, ma'am? Because it will come,
Yeah.
I think it will be a term, so that you have a different way. You are solving in a different way.
Okay, so the point is, like, you first figure out if you can get the roots of this equation. If you are able to factorize this in terms of s plus a into s plus b, the denominator, then you separate out this s plus a and s plus b and you write in terms of a and b like I had shown before in the earlier example. So if this denominator can be factorized, you can write it separate out the factorials and like the different factors and write it in terms of a by s plus a, b by s plus b. So whenever this s square term is there, it either can be factorized or written in terms of some s plus some constant whole square plus omega square. So if it can be written like this, it can be converted to if depending on whether in the numerator s is present or not, to cos or sine. And if it can be factorized, then it can be written in terms of e to the power some at u of t. So these are the two ways you can apply inverse Laplace transform to solve this, right? Now try factorizing like s square plus 14s plus 74. First the basic trial would be to find out the roots. So let's find out the roots. So I'll just write it here. So let's say you have s square plus 14s plus 74. So s will be equal to minus b plus minus root over b square minus 4ac 4 into 74 by twicing. Minus 14 plus minus, let's do this, 14 into 14 minus 4 into 74. So this comes out to be minus 100 by 2. So this kind of becomes as a complex. Now do you know, like, if this was a complex root, so it will be minus 14 plus minus I10. You do not have any Laplace transform to actually use you do not have among the known that I have shown until now to inverse, take an inverse Laplace transform of this imaginary term, right? So you will ditch the approach of forming these factorials. Instead of that, you will try to figure out like it is of the form s plus a some whole square, and whatever the rest of the term will be, you can write it in terms of omega square. Suppose the equation had been s square plus 14s plus suppose instead of 74 it would have been 73, suppose. So you would have written s square plus s plus 7 whole square. So it will be 49 minus 73 would have been 24. So 24 can be written as square root of 24 whole square. So your omega will be root over 24 instead of, in this case when it is 74 it is 5. So whatever the remaining
Yes, this is.
would be.
I won't, ma'am. Okay, ma'am. I got the point.
You got the point, right?
Yes, ma'am. Yes, ma'am.
So okay, let's go ahead and solve it. So yeah, we have this. So let's like write the in proper fashion. 15 into 222 by 9324. So it can be cancelled and written in terms of 5 by 14. I see 5 by 14. Now this expression is in terms of uh, 1 by s plus a whole square plus omega square. So in case of sine, like take the inverse Laplace transform of the sine function, so it has to be, omega has to be on the numerator, right? So we will multiply the numerator and denominator by omega, and then we can take the inverse Laplace transform. So what we do is, this 5 we take inside, so it will be 1 by 14, 5 by s plus 7 whole square plus 5 square. Right? Now it is in the form of sine inverse of omega t. So 1 by 14, we can, here omega is equal to 5. So sine of 5 omega t, right? Sorry, here omega is 5, so sine of 5t. Now s is s plus something, right? So it has to be multiplied by, it has to be multiplied by e to the power 80 minus 80, right? So here a is equal to minus 7. This is fine.
Yes, ma'am.
Yes,
So
ma'am.
so we have, like, until now it was in form of frequency domain, now we have in terms of time domain. So in the question what you were asked is to figure out a1 phi 1, okay, and the expression itself is in sine. So you have to find the coefficient, the value of k, omega, and this phi 1. So whatever the equation that we got, from here we can say a1 will be equal to 1 by 14, which is 0.0714. Omega is equal to 5, k is equal to, let's see how the expression is, it is in minus kt, right? So k will be equal to 7, and in this case phi will be equal to 0, because there is nothing like plus like there is no phase into that. It is sine of 5t. Had it been sine of 5t plus some 2 point something, whatever, like some x value, then this would have been the phi. So since nothing is here, it is phi is equal to 0. Okay. So similarly, in the same fashion, you can find I2 of t, right? So let's calculate I2 of t. So let me see if I can, no. So can anyone tell me how to find I2 of t? Exactly in the same fashion. I2 of s will be,
Is into 42s
yes,
upon 42s plus 22.
and I of s is, we have already seen, it is 15 by 9324. And in the numerator you have I'll just write it since in the previous one only we have just find out. It will be the same thing, so I will write it in terms of s square plus omega square, right? So now you cancel this two. You have 42 into 15 by 9324. S is on the numerator and s plus 7 whole square plus 5 square. Now this is in the denominator is somewhat in the form where we can take a cosine Laplace inverse of cosine function. Unfortunately, there has to be plus 7 on the numerator, which is not there. So what we can do is we can write it. Let's like simplify the expression outside. So it is 42 into 15 by 9325. So let's check 1 second. I think it's 9324. Sorry, I had written a mistake. So it is 9324. Yeah, so it is 9324, right? So 42 into 15 by 9324. So it is 5 by 74. Now this expression, what you can do is, in order to make it like so as to convert it in cos kind of Laplace transformation of cosine function, you add 7 because it has to be s plus a on the numerator too. So if it is e to the power a t multiplied by cos of omega t, then both the numerator and denominator has to be s plus a and s plus a, right? So you can write it as plus 7 minus 7. So s plus 7 whole square plus 5 square. Now you separate out this term and this term. So 5 by 74 will remain outside. It's just if you start practicing, you will figure out like at the end you will have to figure out how to separate out the terms and make it in some format so that you can take the inverse Laplace transform. So the first one is s plus 7 by s plus 7 whole square plus 5 square minus 7 by s plus 7 whole square plus 5 square. Now this is perfectly in the form of e to the power minus 7t cos of 5t, right? But in this case what happens is that in the numerator, since there is no s, so this will be in the form of sine of omega t, but for that omega has to be on the numerator, which is not there. So we can write it as 5 by 74 s plus 7. You don't need to write so many steps, like I'm just showing it for convenience. So 7, you multiply numerator and denominator by 5. So it is s square plus 7 whole square plus 5 square. Now this entire expression is in the form of e to the power minus 70 cos sine of 5t. So we take, since both the expressions, the inverse Laplace transform can be taken, we take I of 2 it is equal to 5 by 74 into e to the power minus 70 cos of 5t u of t minus 7 by 5 e to the power minus 70 sine of 5t ut. Is it okay with everyone until now?
Yes, ma'am.
But
Yes,
sorry,
ma'am.
yeah, but you see in the question it is given in terms of sine t plus some phi. So you cannot end up the expression as we have got like this. So we have to further simplify it.
Madam,
Yes,
hello? Ma'am, there you wrote a square plus 7 whole square.
yes.
And from down to second step.
From down second step.
5
Okay, this one.
sine. Yes, ma'am. S square plus 7 whole square, or is it S plus 7 whole square?
Sorry, it should be s plus 7 whole square.
Okay, thank
So
you.
it's just a numerator, denominator. I'm writing it by separating out this term and this term. Yeah. So up to this clear, right?
Just 1 second now.
Yes.
In the third step,
Third
we have
step,
taken
yes.
s plus 7 and minus 7.
Yes.
Instead of that, like how we did in the previous one, we could have just taken 5 to the numerator and go
But
with sign
but
directly.
but s is there, right? See,
Oh, that is yes. Okay, okay, okay,
yeah.
okay. I thought it was 5.
No. This is s. So I'll better write it like this. Yeah. So s and 5 kind of looks alike, sorry. So, yeah. This is fine, right? Up to this much is clear?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Now we have to simplify this term which is inside the bracket in terms of uh, cos A cos B, so that we write it in terms of like cos of something plus something, or sine of something plus something. So how are we going to do that? Let's first simplify, like take out u of t and e of minus t, and I'll like write it in a more proper format. So what I do is, outside there is 5 by 74. So I take 5 inside. E to the power minus 70, it is there in both the terms, like e to the power minus 70, e to the power minus 70, and ut is there. These two things I take it outside, because it doesn't come in the cos or sine formula, u of t. This part I have taken out. Now the 5 that is here, I am taking it inside, so that this denominator which is here, it gets cancelled, right? So it will be, since I am taking the 5 inside, cos of 5t minus 7 sine of 5t. Is it fine? I'm just taking this 5 which is outside inside the bracket. So this denominator gets cancelled, and there is a 5, additional 5 that comes out here. And I'm taking out the e of minus t and u of t outside the bracket, because you don't really, like, it is common in both. Now this expression you have to write in terms of either cos of a plus b or sine of a plus b. Now since there is a so let's calculate. So how do you like convert the expression like that? What you can do is, we multiply with a normalizing constant. So for example, so we have 5 square plus 7 square is equal to 25 plus 49, which is 74, right? So we take the magnitude, like if there is a into cos of something minus b into cos of, sine of something, what we can do is, we normalize this by multiplying the magnitude in the numerator and denominator. Suppose a square plus b square, and we write it like this, a square plus b square. So this is basically cancelling out and giving out the same expression. Why do we do this? Because then we can write a by square root of a square plus b square cos of theta minus b by square root of a square plus b square sine of theta. Consider this to be cos phi, consider this to be sine phi. Now we know universally cos square phi plus sine square phi has to be 1. This condition has to be satisfied. So when we normalize these constants which are there, you will see we get back to this expression. For example, in this case, if we write cos square phi plus sin square phi, it will be a square by square root of a plus b whole square is a square plus b square plus b square, again square, like this is basically square root of whole square, right? Whole square. So this comes out to be a square plus b square by a square plus b square, which is equal to 1. So the criteria is satisfied. So the trick to write this kind of expression in terms of cos of something into cos of something minus sine of something into sine of something is normalize the coefficients. So in order to normalize, what we will do, we will multiply the numerator and denominator by square root of 74. So it is 5 by square root of 74. So what I have done is multiply the numerator and the denominator by square root of 74. Cos of 5t minus 7 by square root of
We
74.
already have a by root 1 by 74 outside, right? Can't we just take that inside
Yes, like it's
rather
the
than
same thing. Like,
multiplying?
yeah, either you can write it as like this. So it is the same thing, right? So 1 by square root of 74 will be outside. That's it. So there will be this 1 by square root of 74 that is outside in here, e to the power minus 70 u of t. Now consider this to be cos phi and consider this to be sin phi. When you calculate cos square phi plus sin square phi, it will be 1. So this is in the term of cos c into cos d minus sin c into sin d. So basically the theta that will be, so we take as cos phi to be 5 by 7 square root of 74 and sin phi is equal to 7 by square root of 74. So how can we calculate phi? Phi is, let's say tan phi is sin phi by cos phi, so it is 7 by 5. So phi is tan inverse of 7 by 5. Is this fine? So here we can write it, this is in the form of cos phi, cos c plus cos d, cos c into cos d minus sin c into sin d. So we can write this in terms of cos of c minus d, sorry, c plus d. In case of cos, it is plus. So whatever this phi will be, this will be equal to tan inverse of 7 by 5. Is this clear until now?
Yes, ma'am. Yes, ma'am.
It is clear, right? So I'll just move to the next page. So now you have I of, sorry, this is I2 of S, not T. Okay, now you have taken in terms of T. Okay, so I2 of T will be equal to, so now we start simplifying. 1 by square root of 74 is 1 divided by square root of 0.1162. So it is 0.1162 e to the power minus 7t cos of 5t plus, we need to find tan inverse of 7 by 5. Please note that this should be, like for example, tan inverse of 7 by 5 is 54.46, but this is in degrees, but this 5t, this is in radians because this frequency is radian per second, right? So this unit needs to be balanced. We cannot simply write here 54.46. We have to convert this into radians. So we have 90 degree equal to pi by 2 radian. So 54.46 degree is pi by 180 into 54.46. So 4 divided by 180. So this comes out to be 0.95. So cos of 5t plus 0.95. Right? Now let's look into the question. So in the question it is given in terms of sine. So we can also write this in terms of sine. So 0.1162 e to the power minus 7t. We know sine of 90 degree plus theta is equal to cos theta, right? So we can write it in terms of sine. Sine of, but then again 90 degree has to be written in terms of radian. Pi by 2 plus 5t plus 0.95. So this is 0.1162 e to the power minus 7t sine of 5t plus, so pi by 2. Pi divided by 2 is 1.57 plus 0.95. So now whatever is asked in the question, A2 will be equal to 0.1162 and phi 2 will be equal to 1.57 plus 0.95, which is 2.52. I hope that's all it is asked in the question. So yeah, it's pretty much it. Now the last thing is to calculate V of C. So since we have already calculated this I1 and I2, we can also calculate the voltage across this. Since we already have the impedance here and we have calculated I1 and I2 in terms of suppose for example, now to find VC, so whatever the impedance here would be, this is Z. So this is the VC. So IS is flowing, we have the value of IS and we have Z, so we can calculate VC. VC will be equal to IS into Z, right? Is it fine?
Yes.
Yes, ma'am.
Okay. So VC in terms of frequency domain is I of S into Z. So I of S is 15 by 9324. Okay. 15 by 9324 into 42s plus 222. I'll write the denominator in terms of the expression that we already got. S square plus 14, S square plus 7. Sorry, S plus 7 whole square. S plus 7 whole square plus 5 square into Z. Z is 42s plus into 222 by 42s plus, so I'll write S like this, 222. We can get rid of this term. So it will be similar to 15 by 9324 into 42 into 222, and it will be S by S plus 7 whole square plus 5 square. So can you it is exactly similar way in which we found the current I2, right? So can you write it, do it on your own right now? Will it be fine? Will you be able to do it, or should we do it together?
We can do it.
We'll do it now.
So will you be doing it on your own, or should I do it?
We will do it, madam.
On
Proceed
your
further.
by yourself, right?
Yes, yes.
Okay, so this is exactly the similar way we had figured out I2. So again, you will come across an expression like this. You have to take out
Ma'am,
the cos and sin. Yes,
ma'am,
yes.
here the in second line 5 by root over 74 taken as cos 5. Ma'am, in last page,
Previous page.
previous page, ma'am.
Yeah,
In second line, ma'am, we
yeah.
take the 5 by root over 74 as cos 5.
Yes.
We can also take as sin 5.
Yes, yes, you can take a sine phi, then you will come across like the direct value of tan like tan inverse of whatever it will be. It will be 5 by 7, I'm guessing.
We
Either way
can
you
and
can.
thereby we can directly find the sign term, not
Yes, yes.
convert
Then
again.
yes, then it will be sine of 5t minus of tan inverse something, right? Because in case of sine, this negative sign will be there.
Yes, I got it.
Yeah.
Madam, can you explain that step once again?
So here I have taken 5 by square root of 74 as cos of phi. Instead of that, if you take 5 by square root of 74 as sine of suppose phi dash, and this one as cos of phi dash, and then like write it, then this will be sine of c into cos of uh, sine of c into cos of d minus cos of d into sine of why I have written in terms of cos is because it is easier to write like something plus theta, like see, cos of a plus b is cos a cos b minus sin a sin b. Now you do not know whether this 5t or this angle is greater or lesser, because in this case when there is a negative sign you do not know which one to take, like c, on which one to take d. It could either be like 5t minus some phi or some phi minus 5t. You do not know which way to take. So the best option, that is why I had taken in terms of cos, so that it comes with a positive sign. That way there is no mistake. Did you
Okay,
get it?
thank you. Mm.
So whenever there is a positive sign, you can take anything, but if there is a negative sign, it's best option that you take in terms of cos and sin. If it is a positive sign, then take cos sign, so that it will be sine of something plus something. Sine of c plus d, suppose. So depending on the sign here, since you are not aware of 5t, t could be any value, so that is why I had taken this as cos and not as sine. Okay.
Yes, ma'am.
Okay. So similarly for this case also you will solve it out. I'm just writing out the answer so that you can solve and verify later on, because we are kind of uh, behind schedule. So I'll just write down the answer. Please solve this because you will get similar kind of problems. So here a like AV, whatever it will come in terms of a constant, and e to the power minus 7t kind of a thing, u of t into cos of something plus something, right? So in that case AV will be equal to, just hold on, yeah, AV is 25.08 and phi again will be 2.52 and omega and k are the same thing. So you will come up with this constant and this phi value, which is equal to here as shown. Okay. So I hope you are now able to understand how to solve this problem. If there is any question you can ask, otherwise we'll move to the next problem. Is it clear to everyone?
Yes, ma'am.
Okay.
Yes, ma'am.
So for the next problem, there is a circuit which has a primary and secondary. The dot connection is shown as shown in this figure. So in this case, you see in one of the dot the current is going out, whereas in the other dot the current is going in when the switch is closed. And it is shown that there is no current flowing through the circuit before, so initial conditions are 0. Only the dot convention here is different. So we have to solve like we had solved the dot connection problems in our previous class. This is exactly the same, but we will convert it to frequency domain, right? So the primary of the circuit can be drawn. Suppose it is now in time domain itself. How we solved the in the previous class? How did we solve? We took into account the mutual inductance and the self inductance, right? So the mutual inductance would be, since the current is flowing like this, the self inductance voltage drop will be somewhat like this, L di by dt, since this is I1 and this is 20 volt, 5 ohm. So the mutual inductance, since the dot connections are opposite, in this case the current is flowing out of the dot and in this case the current is flowing through the dot. So the mutual inductance will oppose this. So it will have the reverse sign of L di2 by dt. And the secondary of the circuit would be, so if this is I2 and sorry, this is 5 ohm, so the voltage drop across this will be plus minus 5 I2 and the current will enter here. So the self inductance will be in this notation. So L2, so let this be L1, L2 di2 by dt, and the mutual inductance will be in the opposite sign. So M di1 by dt. We used to solve like this, but now we will do the same thing in case of frequency domain. We will redraw the circuit. So this 20 volt will become 20 by S. Current flowing will be I of S. Resistance will be as it is. Now both the self and the mutual inductance need to be taken into account. So the sign will be like this. Now M here is given as 14 Henry, right? So it is 14 into S. So M or L, whichever the point is, both are inductance. So inductance into some differential of current. So it will be in frequency domain 14 into S, right? 14 into S into, in this case, I2 of S, since it is di2 by dt, because we know Laplace transform of di by dt, dx by dt is equal to S into x of S, right?
Ma'am,
Yes.
M is equal to 1.4, na?
Yes, yes, it is 1.4. Sorry, I have written 1. It is 1.4. And the self-inductance is 4.9 into S into I1 of S. So this is loop 1. So we can apply KVL in loop 1. So applying KVL,
Yes, ma'am. One of S, ma'am.
yes.
You have written it I of S in the first loop because that is in the question they have given it as I1 of T.
Yeah, so it is I1 I have written, right?
Here, ma'am.
Oh,
In
sorry,
the
sorry. Yeah, it will be I1. Sorry. Yes. So since two different currents are flowing, it will be, we are just taking the like into the frequency domain, so it will be I1 of S. So now we apply KVL in this loop, it will be, I'll just use a different pen. So if we go in this direction, it will be 20 by S, then minus 5 I1 of S plus 1.4 s I2 of s minus 4.9 s I1 of s. This is fine, right? So
Yes, ma'am.
yeah, we'll write this as equation 1. Okay. For the second equation, for the second loop, so this is I2.
Equal to 0.
Sorry,
Equal to 0 in the first.
sorry.
In the first expression, it will
Yeah.
be equal to 0, man.
Yes, yes.
In the first expression, it will equal to 0. The whole.
Yeah. So yeah, we are applying KVL. This will be equal to 0. So in this case, mutual inductance is 1.4 s and self inductance is 0.4. And resistance is 5. So the voltage drop will be 5 into I2 of s. And in this case, this will be I1 of s. This is I2 of s. So now we apply KVL in loop 2. So it will be 1.4 I1 of s minus 5 I2 of s minus 0.4 I2 of s will be equal to 0. So we can write I2 in terms of I1. So let us separate out I2 and I1. So 5 plus 0.4 s, so there will be a s here, sorry, s I2 will be equal to 1.4 I1 of s, right? We have taken this one on the other side and taken I2 as common. So I2 can be written in terms of 1.4 s by 5 plus 0.4 s into I1. Let this be equation 2. Now we can write the equation 1, like substitute the value of I2 in equation 1. So let's take the equation 1, which is, so equation 1 implies 20 by s. So if we take common I1, so let's take the entire thing on the right hand side. So then we will simplify. 5 minus 4, 5 plus 4.9 s into I1 minus 1.4 s I2. So now we are substituting the value of I1 from expression 2. So it is 5.49, 5 plus 4.9 s I1 of s minus 1.4 s into the expression we had from 2, right? So it is 1.4 s by 5 plus 0.4 s. Is this fine? This is fine, right?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes, ma'am.
So now we have to simplify the expression. So I of s, we are taking it out. So it will be 5 plus 4.9 s into 5 plus 0.4 s minus 1.4 whole square s by 5 plus 0.4 s. So just simplifying this out, where is my calculator? So 5 into 5 is 25 plus 4.9 into 5 is 24.5 plus 5 into 0.4 is 2 plus 4.9 into 0.4, which is 1.96. Okay, and this will be s square. Now 1.4, sorry, this s and this s multiplied, it will be s square. So 1.4 square is, so it is again 1.96 into s square, sorry, 5 plus 0.4 s into I1 of s. So this will get cancelled. So now we can write I1 of s and we take this entire term on the left, left hand side. So I1 of s will be equal to, so on the right hand we had 20 by s. So it will be 20 by s and we take the whatever was on that side on the other side. So it is 25 plus 24.5 plus 2 s, it is 25 plus 26.5 s, and it is 5 plus 0.4 s. So it is 5 plus 0.4 s. This is what we had in here. So we had brought it to the denominator, and now we will simplify. So it is 20 into 5 plus 0.4 s by s into 26.5 s plus 25. So in denominator we have, like I'll write the s properly. So in denominator we have something into s, but in order to take the reverse, like the inverse Laplace transform, you will have to get rid of the coefficient that are with s. So what we will do is, we can either divide the numerator and denominator by 26.5, right? So we take 1 by 26.5 outside. So it will be in the form of s into s plus 25 by 26.5. We are just writing in terms of s plus a so that we can take the inverse Laplace transform. And the numerator, so let us just multiply and write it. So 20 into 5 is 100 plus it is 8s. Okay, this is the expression we have until now. So since this is not a very straightforward one that we could write in terms of a plus b, so we will write this expression in terms of partial fraction. So let this be outside 26.5. So we can write it in terms of a by s plus b by s plus 25 by 26.5. Okay, is this fine? So what we are doing is, now we will be
Ma'am, what
solving
happens
for
to
appendix.
numerator, ma'am?
Sorry.
Okay, ma'am, got it, got it.
So what we will be doing is, we will be equating this and trying to find a and b. So it is 1 by 26.5 100 plus 8 is by s into s plus 25 by 26.5 is actually now written in terms of 1 by 26.5 a by s plus a by b by s into 25 by 26.5. Okay, So these two things we can cancel out. So we can write this as 100 plus 8s, and if we take this denominator to the other side, it will be a into s plus 25 by 26.5 plus b into s, right? Now we put in this expression, let's write this expression as a. In a we put different values of s in order to figure out a and b. So the first step is putting s equal to 0 in expression a. When we do that, it becomes 100 equal to, so s is equal to 0, so it is a into 25 by 26.5 plus 0, right? So a is equal to 100 by 25 into 26.5. So it is 4 into 26.5. We will not multiply this 26.5 since it is outside. We may easily cancel it at some point. So right now a is this much. Okay. Now how to find b? Let me take the different color. So to find b, if we can make this part to be 0, we can easily find out b. So in order to find b, what we will do is put s equal to minus 25 by 26.5, right? So it will be 100 plus 8 into minus 25 by 26.5, and the terms of a will go to 0, so a into 0 will be 0 plus b into minus 25 by 26.5. So b comes out to be so yeah, so it is minus 25 by 26.5, so it is 2650 minus 8 into 25. 8 into 25 is 200 by 26.5. Let me just cancel this too. So b is equal to minus, so no, it is 26.5 minus 200, so 2450 by minus 25, which is equal to minus 98. Okay, so we find the value of a and b. So you have to figure out the value of a and b and then plug into this particular expression. So I'll take some more pages. So when we write it, now the expression will be I1 of s is equal to 1 by 26.5. A we have gotten to be 4 into 26.5. 4 into 26.5 by s, and b is minus 98 by 20, s plus 25 by 26.5. Is this fine?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Now if you take a Laplace inverse, so it is 1 by 26.5. So 1 by s is u of t, right? And 1 by s plus a is e to the power minus at into u of t. This is the expression. So we take 26.5 inside, it becomes 4 minus 98 by 26.5 is, it is 3.698 into e to the power minus, we'll calculate this later, so 26.5t whole u of t. So this is the expression of I1t. So in the question it is asked, you will have to find a1, b1 and tau. A2, B2 is from the other expression. So a1 is equal to, since the expression is written in terms of some constant plus b1 e to the power something into u of t. So similarly in this case we got in the similar format, a1 is equal to 4, b1 is equal to minus 3.698, and I think, yes, tau is in the denominator, so tau is equal to 26.5 by 25. So it will be 1.06. Okay, this is fine. Now just plug this I1 of t in equation 2. You have the relation between I2 of s and I1 of s, right? So I2 of s will be 1.4s by 5 plus 0.4s. 1.4s by 5 plus 0.4s into so you can just plug in this particular value, right? This particular value you can put it in, because later on we separate the function to take the Laplace inverse. So this I1 of s, this particular expression, we plug it in equation 2. So it is so 100 plus 8s 8s by s plus 26.5 into 1 by 26.5. Okay. So right now you have, you can cancel this. So just take out 20 out of here. So it is 1.4s. The more simplified the expression you can make, the better it will be. So it is 5 plus 0.4s. So if we take out 20 from here, so it will be 5 plus 0.4s by 26.5 into s plus 25 by 26.5. So this will get cancelled, and then again s from here and here will get cancelled, right? So you don't really need to write this s. So it will be I2 of s will be equal to 1.4 into 20 by 26.5 into 1 by s plus 25 by 26.5. This is more a more simplified form, like this is in the form of s plus a. So if you take Laplace inverse directly, it will be 1.4 into 20 is 28 by 26.5 into e to the power minus 80, which is 25 by 26t into u of t, right? This is I2 of t, the expression of I2 of t. Now in the question it is asked to find A2, B2 of this expression. So in this case there is no constant. In the question it is given I2 of t as a2 plus b2 e to the power minus t by tau into u of t. It is written like this, but in this case there is no constant here. It only this e to the power term is present, so it can be written as 0 plus like this, right? So a2 will be equal to 0, b2 will be equal to 28 by 26.5. So 28 divided by 26.5 is 1.0566, and tau will be same as before, that is 26 by 20, 26.5 by 25, which comes out to be 1.06. So this is what has been asked in the question. So is this clear to everyone?
Yes, ma'am.
Yes.
Okay. Can we move to the next question?
Yes, ma'am.
Excuse me, madam.
Yes.
First slide of this question.
First.
First slide of this question, where question was written. Just a minute.
Yeah.
Next slide, madam.
Okay.
Just a minute. Just a minute.
Okay.
Okay, madam. Okay.
Okay. So we'll move to the next question that we have. This is the last question we have for today. In this case, it is written like the switch the switch which is given here is closed at t equal to 0, and before that the capacitor was charged to a voltage of 5 volt. Now we have to find the current and the voltage across the capacitor. The current is the series current that is flowing through all the elements, and the condition is given k1 is greater than k2, and we have to find the different constants a, b, c, d, e, f, whichever is given in the question, and k1 and k2. So till now I guess you are now familiar with how to solve this. So first you will convert the circuit to frequency domain, then solve for I1 and I and Vc, and then you can convert it back to the time domain and figure out A, B and C, right? You'll be for this problem you also start doing it and let me know. So first we draw the circuit in frequency domain. Now since the capacitor has an initial voltage, we will write it as a separate voltage term. So this is the source voltage 24 volt which is given. The current is I of S. The voltage drop here will be 22 into I of S. Now for the current it will for the inductor it will be 2 Henry, so 2S. The voltage here it is given as 5 volts, so it will be 5 by S, and C is given as 1 by 56, so 1 by CS is equal to 56 by S, so it will be 56 by S. So now this IS current is flowing this through this circuit, so you can just either apply KVL or just find the voltage difference between this point and this point and calculate I of S. It is up to you. So let's apply KVL. So it is 24 by S minus of 22 into I of S minus 2S into I of S minus 5 by S. So now the voltage drop will be like this, so minus 56 by S into I of S is equal to 0, applying KVL. So we take the I of S term on the other side, So it will be 22 plus 2s plus 56 by s into I of s, and on the right hand side we keep the constant terms which are not there with I of s. So it is 24 by s minus 5 by s. So 24 minus 5 is 19. 19 by s. So now we calculate I of s. I of s will be 9 by s, sorry, 19 by s into 22 plus 2s, 22 plus 2s plus 56 by s. So the this s we take it inside the denominator, so it will become 22s plus 2s square plus 56, right? So 19 we take it outside. Now it is in the form of 2s square plus 22s plus 56. Now can anyone suggest how we can proceed? We have solved earlier problems, so I'm just trying to find out whether you followed it or not. How will we
We
proceed?
can take 2 as a common.
Right. So the first step is to free the s square term. So it will be s square plus 11s plus 28. Then what can we do?
Uh,
7 into 4.
Exactly.
That is the
So
factors.
right. So this
7
term
and
has a
4.
factor of 7 and 4. So it can be written as s plus 7 into s plus 4. So the first step is to check if it has any factors. If yes, then go ahead like this. If not, then go with like cos and sine formula, like write it in terms so that it can be converted back to cos and sine. Since there is a factor, we will go through this way. So now our motto is to separate out these terms. So it is 19 by 2, and the numerator can be written as, suppose, so 7 minus 4 is 3. So we will write it like this, 3 by, either you can write it in terms of a by, like I had shown, a by s plus 7 plus b by s plus 4, but since this is very straightforward, I'll just go ahead like this. So we are just writing 4 because the difference between this and this is 3. So this we can write it, I will write it here. So this can be written as 19 by 6 into, so it can be written as 3. So it can be, now it can be written as s plus 7 minus s minus 4, or minus of s plus 4. It can be written like this. Then if you calculate the denominator, s will get cancelled. 7 minus 4 is 3, and we have 3 in the numerator. So this is fine, right? So now we separate out. It is 19 by 6. You can also go through this way and end up with same values of a and b, which we have now. So it will be 1 by s plus 4 minus 1 by s plus 7. Is this fine? Okay with everyone, right?
Okay, ma'am.
Yeah.
Yes, ma'am.
So now we have I of s to be this, right? Now we can easily take the inverse Laplace transform of this, right? So taking inverse Laplace transform and writing in terms of I of t is 19 by 6 e to the power minus 4t ut and e to the power minus 7t u of t, right? So we can write I of t to be, so in the question it is given in terms of a plus b e to the power something, c e to the power something. So we will write it as 0 plus 19 by 6 e to the power minus 4t, and this there is a minus sign here, so it will be minus 19 by 6 e to the power minus 7t into u of t. So now it is in the similar way it is written in the question. So a, b and c you can figure out. So yeah, so a will be equal to 0, b will be equal to 19 by 6. Let me just calculate. So it is 19 divided by 6 is 3.166. C will be equal to minus 3.166. And you have to find K1 and K2. So this is the K1 and this is K2, right? So K1 is equal to 4, K2 is equal to 7. These are the parameters. Now you have I of t. Can you calculate V of C? So last time what we did was we calculated the equivalent resistance across this, and since V of C will be same because this entire voltage will be divided like between these elements and this. But right now since they are connected in series and there is a source voltage, what we will do is we will calculate VC, like the voltage VC will be the voltage that is coming across here, right, including what the initial condition was. So we will calculate it that way. So VC will be in terms of S, let us write, which is the initial voltage 5 of S plus whatever C, whatever the voltage drop will be from here to here, right? Whatever the voltage drop will be from here to here. So it will be 56 by S into I of S. Okay. Now we already have I of S. So we can just plug in the value 56 by S. I will write S like this, sorry. So I of S, I think the best option would be to put this particular expression. Let me highlight it. Since we had already separated out the term and everything, we can put this expression, right, as I of S. So, sorry. So we'll just plug into this expression, which is 19 by 6 1 by S plus 4 minus 1 by S plus 7. Yeah, this is the expression. So now it is again simplification. So 5 by S will be 5 by S is fine. It is in the form where we can take an inverse. So it is 56 into 19 by 6. 56 into 19 by 6. 177.33. So now if we take S inside, it is in the form of S into S plus 4 minus 1 by S into S plus 7. So again we have to separate out these two terms. So it is 5 by S plus 177.33 into. So this can be written as 1 by S minus 1 by S plus 4. So you just write it in either in terms of A and B and figure out, or you can just take the difference between, like since this is only S, so what can it be written? 4 by S into S plus 4 into 1 by 4. This is what we had taken it outside. Now this can be written as 4 plus s minus s by s into s plus 4. So when we separate this term out, it will be 1 by s minus this ss will get cancelled and it will be s plus 4. So this is exactly what we are doing here. In this case, if we write 1 by s minus 1 by s plus 7, what will be the coefficient here? In here, what will be the coefficient?
1/7.
1 by
Right,
7.
right. So now we can take the inverse Laplace transform because everything is in terms of where we can take the inverse Laplace transform, right? So now we take inverse of it. So it is 5 or what we can do is like extract the 1 by s term together, and so let's simplify the expression further. So 1 by s term we take it together. So it is 5 plus 177.33 by 4. We are just taking this and this outside. Okay, outside and clubbing it with the first term since all these are 1 by s. So 177.33 by 5, sorry, by 7, and we have 177.33 by 4 into 1 by s plus 4. Sorry, this will be negative, and this negative will make this positive, so it will be plus 177.33 by 7 into 1 by s plus 7. Now we can take the inverse Laplace transform. So v of t. So 1 by s is equal to u of t. Now whatever the constant term we have here, let's calculate. 5 plus 177.33 by 4 minus 177.33 by 7. So this constant comes out to be 23.99ish. So it's approximately 24. This part, okay, minus, so 177.33 divided by 4 comes out to be 44.33. So it is 44.33. Now 1 by s plus 4 is e to the power minus 4t u of t, and the other term is 177.33 divided by 7, 25.33. So 25.33 e to the power minus 7t u of t. So this is the final expression, and in the question it is given in terms of a constant e to the power something, e into e to the power something, f into e to the power something. So we have similar kind of expression for this. So we have v of c is equal to, so 24 minus 44.33 e to the power minus 4t plus 25.33 e to the power minus 7t u of t, whole of u of t. So we have the answers. So D, E and F. D is the constant value, which is 24. E is the coefficient of e to the power minus 40, which is minus 44.33, and F is 25.33. So this is pretty much it. Is it clear to everyone?
Yes, ma'am.
Yes.
Yes,
Okay.
ma'am.
If you have any questions to ask, you can ask regarding solving these problems. Otherwise, we can wrap it up for today.
Ma'am, I have one request, ma'am.
Yes.
Ma'am, actually last time I have did electrical machines one course. Sir only taken that course, ma'am.
Okay.
In that course, actually these videos, that is lecturing tutorial videos, they will upload the link of the videos before Wednesday. Wednesday morning they will upload all the links like this tutorial videos. But for this course, they are not uploading those links after the assignment submission date. They are uploading the links. For example, so many students can't see this live interaction, but this recorded video link, if it is available before
So it
submission
is
of the.
so it is supposed to be available, right? Wait, let me check. So
But
if you this is
it is not.
your this is the thing that you have, no? So
Yes,
you
ma'am,
see
yes.
problem solving sessions. If you go here, let me 1 second. So if you see this, you have like week 0, week 1, week 2, week 3, week 7 like this. Then when
Yes,
you
ma'am.
go to this problem solving sessions, if you click here, you will like get this, click here, like you will get this link. If you click
Yes,
on
ma'am.
this link, you will see all the videos by different TAs are updated. So there are 3
Ma'am,
TAs for this course. So I am uploading mine in like you figure out which week and whichever the video is. For example, last week was week 4. Although you are doing the assignment of week 5, but we are discussing it in week 4. So if you click on this link, you will be able to see the live interaction session. For example, last week's live interaction session, you can see like this. So you see, like
yes,
we had solved
Wednesday,
that. The current is
before
sorry.
Wednesday, it is not available. Week 5, it is not available now.
Sorry?
Tomorrow is the last date to submit the week, which means sixth
Week
week.
5.
You think week 5, but that link it is not available here, ma'am. So that we can't see the video before submission of assignment.
So like I'll be uploading today in this week 5. So whatever the video link will be, I'll be uploading it here. You can view it,
Okay,
right?
okay, okay, okay,
Like I don't know about the other tiers. I'll be uploading it by today. I always upload
okay,
it on the same day.
okay, okay, okay.
Yeah.
I will see it because there
Okay.
is a confusion. Actually, this is sixth week, but it is there as the week 5. That is why I have
Okay.
confused.
Yeah. So it is actually going behind 1 week. So your week 6 assignments, like similar problems are discussed in our week 5.
Okay,
So
okay,
yeah. Okay then. Anything else? So you more or less,
Excuse me, madam.
yes.
I think your session should be 2-3 days before, and it should be this video should be uploaded on the website before 8. Tomorrow is 8. We have to submit the assignment tomorrow. So this session should be available before 2-3 days
Yeah,
on
so the
hand.
thing is,
Yes.
while starting
Suppose
the,
today's session is going on, and suppose someone is some in urgency case and could not attend, so
yeah,
then he will not be able to do the assignment properly.
so like you have an option to do it tomorrow. Like the thing is, we had started
But
off
tomorrow
late.
also it will not be available. Tomorrow, like fifth week video is not available till now.
So I'll be uploading it today only. That is what I was trying to say. Like I'll be uploading it within 1 hour today only.
Okay, madam.
So you can view and do the assignment tonight or tomorrow morning. Because we
Okay,
started off late, no? Like the session actually started off late. 2 weeks of your
okay,
assignments have been uploaded and then only like our interaction session started.
okay.
So like uh, like my sessions
Okay,
are
madam.
scheduled every Tuesday. I can't
If
help.
if you will upload today, then it will serve the purpose.
Yeah, I always upload it on the same day. Only note that like this assignment number, like whichever week that is mentioned here. So in this case, see, week 4 is mentioned here. This is the link of my video. But in this case, the week 5 assignments, like problems rolled out in week 5 of
Okay,
previous
okay,
are discussed. Like don't
okay,
consider this week, only look at the
okay,
last
okay,
video.
okay,
I'll be
okay.
uploading
Got
it
the point.
within 1 hour.
Okay, okay, got the point.
Yeah, yeah. Okay. So, any other question? Any technical question related to this? Like, I hope you got the basic gist of it. Like
Last slide of the question, madam, please.
last slide.
This question. Okay, okay, this one only.
I also upload the like solution, like whatever this PPT which I have worked out the problems. I also upload it in the Drive link. You can both view the video and the PPT. But please note that this will be uploaded in like in the row which is written as week 5 instead of week 6. So basically in all of this problem, first step, figure out how the circuit is. If there is any mutual inductance involved, sort it out, write it in terms of proper equations. Then redraw the circuit in in S domain, work out the solution. Then when you get the final expression, you make sure that you have